A planet 120 light-years away just failed a test. It was never supposed to fail. In April 2025, a team of scientists from Cambridge University announced something that quietly rewrote the rules of the search for extraterrestrial life. They detected a chemical signature on a distant planet, a chemical that, on Earth, has only one known source: biological life. In this video, we're going to break down exactly what they found, why it matters, and why some of the world's most respected astronomers are now saying the words they spent entire careers avoiding. Stay with me, because this one changes everything. To understand why this discovery is so significant, you need to understand the planet itself. K2-18b was first discovered in 2015 by NASA's Kepler Space Telescope. It orbits a red dwarf star called K2-18, located in the constellation Leo. At 120 light-years away, it sounds impossibly distant, but in cosmic terms, it's practically next door. What made K2-18b immediately interesting to researchers was its size. It's roughly 2.6 times the diameter of Earth and about 8.6 times its mass. Scientists classify it as a Hycean world, a theoretical class of planet covered in vast, warm oceans, wrapped in a hydrogen-rich atmosphere. And here is where the story begins. For years, Hycean worlds were considered prime candidates in the search for life. The chemistry is right. The temperatures, in theory, are right. But they were theoretical, speculative, a category built on models and mathematics, not observation. K2-18b was the first real one we could study up close. In 2023, NASA's James Webb Space Telescope, the most powerful observatory ever built, locked onto K2-18b and began analyzing the light filtering through its atmosphere. What it found in that first pass was already extraordinary: carbon dioxide, methane, and trace hints of something else, something scientists weren't ready to talk about publicly. Not yet. That something else was dimethyl sulfide, DMS. On Earth, dimethyl sulfide is produced almost exclusively by marine phytoplankton, microscopic organisms living in the ocean. When these organisms metabolize, they release DMS into the atmosphere. It's part of Earth's biological cycle. It's the smell of the sea, and crucially, no known geological or chemical process produces it in significant quantities without life. When the 2023 Webb data was published, the DMS signal was there, but it was faint. Too faint to be statistically conclusive. The scientific community, rightly cautious, said, "Interesting, but not confirmed. Keep looking." So, they kept looking. The Cambridge team, led by astrophysicist Professor Niku Madhusudan, returned to K2-18b with additional observation time, more data, more scrutiny. And in their April 2025 paper, they reported the DMS signal had not only persisted, it had strengthened. The concentration of dimethyl sulfide in the atmosphere of K2-18b was detected at levels thousands of times higher than what you'd find in Earth's atmosphere. Thousands of times higher. That's not a background reading. That's not an instrument glitch. That is a signal demanding explanation. What investigators found next shocked everyone. When the team ran atmospheric models, simulating every known non-biological process that could produce DMS, none of them came close to accounting for the levels detected. The chemistry simply doesn't work without a biological source. at least not any chemistry we currently understand. Let's be precise about what the evidence actually shows, because this is where precision matters. The James Webb Space Telescope detects chemicals using a method called transmission spectroscopy. As K2-18B passes in front of its star, starlight filters through the planet's atmosphere. Different molecules absorb different wavelengths of light. The telescope reads those wavelengths like a fingerprint and identifies exactly what's present. The DMS fingerprint on K2-18B was detected across multiple observation windows. It wasn't a one-time anomaly. The signal was reproducible. Professor Madhusudan stated publicly, "The tentative evidence for DMS is intriguing and, if confirmed, could point towards a biosphere." That is a measured, careful statement from a scientist who has spent years studying this planet, and he is not alone. Dr. John T. Horner, an astrobiologist at the University of Southern Queensland, described the findings as genuinely exciting while urging caution. Dr. Sarah Seeger at MIT, one of the pioneers of exoplanet atmospheric research, has long argued that a confirmed DMS detection on a Hycean world would constitute the strongest evidence for extraterrestrial life ever recorded. We are not there yet. The scientific community is careful, deliberately, responsibly careful, but we are closer than we have ever been. The data is peer-reviewed. The telescope is the most precise instrument humanity has ever pointed at the sky, and the signal is getting stronger. So what is actually happening on K2-18b? There are three serious theories currently being debated. Theory 1. There is microbial life in the ocean. If K2-18b's surface is covered by a warm, shallow ocean, as Hycean models suggest, it could host vast communities of microorganisms similar to Earth's marine phytoplankton. These organisms could be producing DMS at scale, releasing it into the hydrogen atmosphere above. Simple, ancient, alive. Theory 2. We don't understand the chemistry yet. Some scientists argue there may be exotic, non-biological chemical reactions occurring in hydrogen-dominated atmospheres that we haven't modeled correctly. Perhaps under extreme pressure, or in the presence of unique stellar radiation, DMS can be synthesized abiotically at high concentrations. It's possible, but no one has demonstrated it, and the models so far don't support it. Theory 3. The detection itself is incomplete. A minority of researchers suggest the DMS signal may be a misidentification, another molecule with a similar spectral fingerprint that the telescope is conflating with dimethyl sulfide. This is a legitimate scientific concern. It is why further observation is ongoing. But here is what's important. Even the skeptical theories take the signal seriously. No credible scientist is dismissing it. Here is the part that should genuinely stop you in your tracks. If the DMS signal is confirmed, not speculated, confirmed, it would mean life exists beyond Earth. Full stop. Not intelligent life, not civilizations, but life. The biological spark. The thing that changes the answer to the oldest question humanity has ever asked. And consider this. K2-18b is 120 light-years away. It is one planet, around one star, in a galaxy containing an estimated 400 billion stars. We pointed one telescope at one world, and within years of having the capability to look, we may have already found the answer. The universe is not empty. It never was. The Cambridge team's next observation window is expected in late 2025. That data will either confirm or complicate everything. Either outcome matters. Either outcome moves science forward in a direction it has never moved before. We may already be living through the moment. So, do you think the DMS signal is biological? Is this the proof we've been waiting for? Or are we reading too much into the data? Drop your answer in the comments right now, because I want to know where you stand on this. And if this video changed the way you think about what might be out there, watch our video on the James Webb Telescope's most disturbing deep field discoveries. Because K2-18B is not the only thing Webb has found that science is struggling to explain. I'll see you in the next one.